Welcome to the deep dive, ready to be the life of the party. Today, we're diving into something that'll make you the AI whisperer in the room. How to really tell if a machine learning algorithm is, actually any good.
Sounds intriguing.
Right, because AI is so hot right now, but it's easy to get lost in all the hype. So today, we're all about giving you the tools to see through the jargon and really understand those performance metrics. Think of it like this.
Okay, I'm listening.
We're going deep into a research paper by Gürol Canbek. The title, PToPI, a comprehensive review, analysis, and knowledge representation of binary classification performance measures metrics.
Catchy.
I know, right? But seriously, this paper is a gem. It's like a guidebook, leading us through the wilderness of machine learning metrics to uncover the ones that truly pack a punch. And lucky for us, we have an awesome expert here to help us decipher it all.
Well, thanks for having me. I have to admit, even for someone like me, the world of machine learning metrics can be a bit overwhelming. So many ways to measure performance, and it's not always obvious which ones really matter.
And that's exactly what makes this paper so cool. It starts with a real-world case study about classifying mobile malware. And get this, even within that one specific area, researchers use different terms for the same metrics.
Oh, I've been there. It's like everyone's speaking a different language.
Exactly. For instance, detection rate is sometimes used for accuracy, other times for true positive rate, sometimes even for positive predictive value. Talk about confusing. So before we even get into the nuts and bolts of specific metrics, can you help us understand why this whole field feels like a jumbled box of puzzle pieces?
Well, I think it's because machine learning pulls from so many different disciplines. Statistics, medicine, computer science, the list goes on. Each field has its own lingo, its own traditions. Mix them all together and things can get a bit messy.
It's like trying to bake a cake using a recipe written in 5 different languages. You might end up with something delicious, but getting there could be interesting.
Exactly. That lack of consistency makes it really hard to compare results across different studies. It's also tricky to know if someone's bragging about their AI's accuracy if we don't even agree on what accuracy means in that context.
It's like we're arguing about apples and oranges when we can't even agree on what an apple is. So how does this paper help us navigate this metric maze?
Well, it starts by making a really important distinction between two terms we often use interchangeably, measures and metrics.
Ooh, this is something I was never quite clear on. Can you break it down for us? Like, why does it even matter?
Think of it like the difference between, say, raw ingredients and a delicious finished dish. A measure is like a single ingredient, a number straight from your data. It gives you a data point, but by itself, it doesn't tell you a whole lot. Like flour in a recipe is essential, but not very satisfying on its own right.
Okay, I'm getting that. So what's the finished dish in this scenario?
The finished dish is the metric. It combines those raw measures in a way that actually means something, giving you a bigger picture of your model's performance. It's the cake, baked to perfection, using all those individual ingredients.
I love that analogy. So to use an example from the paper, if you look at the prevalence of a disease, that's a measure, just a raw number. But a model's accuracy in diagnosing that disease, that's a metric because it brings together multiple measures to tell us how well the model is really doing.
You got it. It's about going beyond isolated data points to see the bigger picture. And that's where PToPI comes in the most exciting part of this paper, in my opinion.
And this is what blew my mind. PToPI stands for Periodic Table of Performance Instruments. You had me at periodic table. So we're talking a visual table, like the one with all the elements, but for machine learning metrics.
Exactly. Imagine a table organizing 57 different performance instruments. Not just the common ones, but some more niche ones too.
That sounds incredibly useful. But why a table? What makes this way of organizing metrics so special?
It's all about the power of visuals. Just like the periodic table, P2PI uses colors, shapes, and positioning to show us the relationships between different metrics instantly.
Ah, so instead of just seeing a jumble of terms, you instantly grasp how they connect. That's clever. What kind of relationships are we talking about here?
Well, for starters, it clearly separates measures and metrics, those raw ingredients, versus the final dishes. Helps you see which metrics are built on which measures. But it gets even cooler. It shows you which metrics are basically saying the same thing, which might be redundant, and which ones are crucial depending on what you want your model to achieve.
So it's like having this cheat sheet that tells you not only what the metrics are, but also how to actually use them strategically. This is already making me feel way more confident about navigating the world of AI, performance and stuff.
And that's exactly the point. It's about giving you the tools to ask the right questions, like having X-ray vision right into those machine learning models.
Instead of being blinded by all the jargon, we can cut through it all and see what's really going on with those performance numbers. It's powerful stuff.
Absolutely. And the paper dives even deeper, introducing some really fascinating concepts to help us understand these relationships between different metrics even better.
Okay, I'll admit, this is where it started to get a little bit complicated for me, like instrument geometry. That sounds like something straight out of Star Trek.
Don't worry, it's not as complex as it sounds. Remember how we talked about measures and metrics? The raw ingredients and then the finished dish.
Right, right. I'm with you.
Well, instrument geometry is all about figuring out which ingredients go into which dishes and what that tells us about the overall flavor, let's say.
Okay, so bear with me here.
No problem. Just think of it this way. Some metrics are all about how well the model's predictions match up with reality. Those are like the core ingredients, the heart of the dish. Other metrics, though, focus on the predictions themselves, whether or not they're actually correct. These are like the spices, adding complexity and nuance to the whole thing.
So instrument geometry is kind of a way to categorize those metrics. Like, is this metric giving me the big picture, or is it more of a zoomed-in detail kind of thing?
You got it. And the paper uses these terms like column geometry, row geometry, and mixed geometry to classify the metrics. It might sound a bit much, but it's really just a way to visualize those relationships in the PToPI table, which makes it way easier to grasp.
So it's all about making those connections clear and visually intuitive.
Got it. That makes a lot of sense when you're dealing with so many different metrics, it's easy to get lost.
Absolutely. And once you've wrapped your head around instrument geometry, the paper throws another curveball. The concept of duality. Okay, duality. I think that one's even more mysterious than instrument geometry. What's the deal with that one?
Think about it like two sides of the same coin.
Yeah.
Different but fundamentally linked. You know, in this case, duality helps us understand that some metrics, even if they have different names and formulas, might actually be measuring complementary parts of the same underlying idea.
Okay, I'm going to need an example here. How does this duality thing actually play out when you're looking at the data?
Sure thing. Let's look at true positive rate and positive predictive value. They're both trying to figure out how well your model's doing, but from totally different angles. True positive rate is all about how many of the actual positives your model correctly picks up.
So that's like, how good is your model at finding the needle in the haystack?
Exactly. Now, flip the script with positive predictive value. It's asking, of all the times your model shouts positive,
Hmm.
how often is it actually right?
So that one's more about the model's precision, how much we can trust it when it makes a positive prediction.
Bingo. That's duality in action. Two seemingly different metrics, but they're really two sides of the same coin, each giving us valuable but distinct insights into how our model's performing.
Wow, that's actually pretty mind-blowing when you think about it. So the paper argues that understanding these dual relationships helps us avoid being tricked by metrics that seem impressive at first glance, but might actually be telling an incomplete story.
Exactly. It's all about understanding the nuances, the limitations of each metric. And PToPI, with its clever organization, makes those connections so much easier to see. It's like it lays it all out for you.
It's like PToPI is a secret decoder ring for understanding the language of machine learning. But wait, there's more, right? The paper also mentions complements.
Right. This one's a bit more straightforward, though. Complements are basically two metrics that represent two sides of the same whole. Know one, and you automatically know the other. Simple as that.
So it's like, if 80% of people love our podcast, fingers crossed, we know 20% don't, or maybe they just haven't listened yet. We'll get them there.
Exactly. And in machine learning, understanding these complement relationships is super helpful because it helps us avoid redundant reporting. Why state both metrics when one's enough? It's all about keeping our data concise and easy to digest.
So it's about cutting through the clutter and zeroing in on the metrics that really give us the information we need. I like it, but hold on, we're not quite done yet, are we? There's also this idea of class counterparts.
Ah, yes. Class counterparts are super relevant when we're dealing with classification tasks, where the model's job is to sort things into different buckets, categories. These metrics are all about comparing how well the model does on each category, so we get a more complete picture.
So instead of just looking at the model's overall performance, we're breaking it down by categories, seeing where it shines and where it might need some work.
Exactly. For example, let's say you're building a model to filter out spam. You wouldn't just want to know how accurately it identifies spam, right? You'd also want to know how good it is at correctly identifying legitimate emails. Those two would be your class counterparts.
So it's like having a report card with separate grades for each subject. Gives you a much better sense of the model's strengths and weaknesses.
And just like with the complements and duality concepts, understanding these class counterparts is super important because it helps us be more discerning about which metrics we decide to focus on and how we interpret them. It's all connected.
Right. So we're basically building up this toolkit of concepts, these different ways of looking at and analyzing machine learning performance. But how does all of this tie back to PToPI? I'm curious.
Well, that's the beauty of P2PI.
Mm.
It doesn't just list out all these metrics. It organizes them in a way that visually highlights all of these relationships. Instrument geometry, duality, complements, class counterparts. It's all woven into the very structure of the table. It's genius, really.
So PToPI is like the Rosetta Stone of machine learning metrics, right? It unlocks this whole other level of understanding. It's not just what the metrics are, but how they all fit together,
Yeah.
how we can use that knowledge to make better decisions about our AI systems. This is huge.
You got it. And that brings us to one of the most powerful things about PTOPI, its ability to reveal these levels of dependencies between different metrics. It's pretty amazing.
Okay, levels of dependencies. Sensing a theme here, PToPI is all about those hidden connections. Tell me more about these levels. What's the deal there?
Think of it like a hierarchy, right? A hierarchy of information. At the very bottom, you've got your raw measures, those basic building blocks we talked about before. But as you go up the levels, you start to encounter metrics that combine those basic measures in increasingly sophisticated ways. It's like building a house, starting with the foundation and building up from there.
So it's like a pyramid with the basic measures at the bottom and then the more complex, insightful metrics at the top, like the top of the food chain.
Exactly. And PTOPI, it actually visually represents this hierarchy, making it crystal clear which metrics are built on top of which others. It's all right there in front of you.
So it's not just this flat list of metrics, it's a multi-layered map that shows us how they're all connected, how they build on each other. That's amazing.
Right. And incredibly useful because understanding these dependencies can help us avoid that redundant reporting, make sure we're capturing all the important stuff, and ultimately make better decisions about our machine learning models. It's a win-win.
It's like P2PI is giving us the keys to the kingdom of machine learning performance measurement, but instead of being overwhelmed, we're actually empowered to explore it with confidence.
Mhm.
This is awesome. This is great. I mean, that's what we're all about here, right? Giving you the tools to decode this whole AI performance thing and understand those metrics like a pro.
Absolutely. It's about moving beyond just blindly trusting or, dismissing things and really understanding enough to make informed decisions about AI and its role, in the world around us.
Right. So to recap our little deep dive here, we've journeyed through this whole world of machine learning metrics using this amazing paper as our guide, especially PToPI. It's brilliant.
Totally agree. Game changer.
Right. We started with that crucial difference between measures and metrics, remembering those raw ingredients, and the final culinary masterpiece.
Love that analogy. It's so true.
Right. And then we tackled those tricky concepts. Instrument geometry, duality, complements, class counterparts. Who comes up with these terms? But seriously, they're not just fancy jargon, are they? They're like really powerful ways of looking at how these metrics all relate to each other.
For sure. And once you get it, it all just clicks into place.
Totally. And we can't forget about the hierarchical nature of metrics,
Yeah.
how they build on each other like a pyramid of, well, insights.
Exactly.
Well-
Layers upon layers of information.
Right. But as with any good deep dive, we don't want to just leave you guys, treading water in this sea of information.
Got to give them something to do with all this knowledge, right?
Exactly. So as we resurface from this deep dive, we always like to leave you with a little something to ponder, food for thought as you go about your day. So here it is. If this PToPI thing is such an amazing framework for understanding machine learning performance, how can we make it more, user-friendly for everyone?
Right. Make it accessible, not just for the data scientists out there.
Exactly. How do we bridge that gap between the technical mumbo-jumbo and everyday language so that anyone, even if they're not, AI experts, can understand what AI can and can't do? What do you think? Something to chew on. Until next time, deep divers, keep exploring, keep asking those tough questions, and keep diving deep.